outside, you'll be spinning around the thing at 113,000 miles per hour. You're going to have a tough time hanging on. That's a lot of outward thrust. You'd have to be very strong, and personally, I can pretty much guarantee you it would be impossible to hang on, even with chains holding you on, because of your inertia. But at any rate, if you could somehow hang on, and then let's just go a step further and say there was an equal and opposite force that allowed you to simply walk around on that outside edge of the gravitron with a diameter of radius of 100 miles. That inward force allowing you to walk around on the outside is a stupid thing to think about, agreed. But keep in mind, we are talking about the conventional model of our world here. Okay, but that inward force allowing you to walk around on the outside would necessarily need to be equal and opposite to the outward thrust. Okay, so it's going to be the exact same amount of force that's causing you to hang on like this and want to be flung off the thing. Okay, it's got to balance that out. It's got to negate that, and we'll call that inward thrust gravity. Okay, because that's exactly what gravity is supposed to do. You mix it in with some barometric pressure, which has all sorts of problems, including the barometric pressure or the atmosphere many miles into the air adjacent to the infinite vacuum of space, somehow not expanding infinitely into the infinite vacuum of space, which doesn't exist, by the way. So at any rate, the amount of force needed to keep you stuck to the side of the gravitron traveling 113,040 miles per hour. If that amount of force was applied to the gentleman in the center, only spinning 3 times per minute, what do you think would happen to him? Now we're talking about a force that's equal to and opposite with the outward thrust generated by the centrifugal force towards the outer edges. If you were to apply the opposite and equal of those centrifugal forces to the man in the center, he would weigh many thousands of times more. He wouldn't weigh just a little bit more. Okay? So anybody who doesn't get this, they use what's called pseudoscience, and I'll explain. Now, it's been a known fact of mariners for at least the last 150 years or so that the southern seas are higher in level than the northern seas. Now, this is sort of a misnomer, north being center of the map, so here's your bullseye, that's the North Pole, northern hemisphere, southern hemisphere. So when I say south, I mean all directions away from the center. That's south, it's always away from the center. Just like north is always towards the center, always towards that bullseye. These are all north, okay, on the true correct flat earth model. So, at any rate, as you travel south away from the center, it's known by mariners, or even then back in the 1800s, that the water levels or the sea level indeed rises up as you travel further and further south and towards the South Pole, which is actually the outer edge or superficial boundary of our world. What this means is there's a much greater pressure towards the center, barometric pressure towards the center, and a decreasing barometric pressure away from the center. That's actually been measured, and that's a known fact. The further and further south you go, especially when you get south of the equator, the barometric pressure slowly decreases, which the water therefore isn't pressed down as much, and it sort of slopes up. It's not nearly as sloped up as this. I mean, we're talking about thousands of miles, so we're talking about, just barely any angle of slope. And it does change in certain places because, again, it's related to the barometric pressure. However, this known fact of barometric pressure is sort of skewed into proving that we live on a spinning globe, and it's used to discredit the argument that I've just made about the centrifugal force at the equator, the equal and opposite of which being applied to someone standing at the North Pole would squash them like a bug. People will say, well, people have been to the North Pole and they weigh slightly more. It's something along the lines of 0.003 grams. I don't even remember. It's ridiculous. These people totally don't get it, but the reason they don't get it is because they're following mathematics, which was designed to assume that the amount of gravity disparity at the North Pole versus at the equator was a measurement done of people's weight. And they assumed this was due to gravity. However, it's obvious to anyone who knows the truth that the difference in weight at the North Pole and the equator is due to barometric pressure. Any mainstream scientist will tell you that the reason our mass is rendered with weight on a scale is due to barometric pressure. Gravity is just supposedly that force that gives us a tendency to be stuck to the Earth, right? It's worth mentioning that the higher we go in altitude, the lighter and lighter we get. That's due to barometric pressure. And it's also worth mentioning that our atmosphere adjacent to the infinite vastness of space disproves the globe model, because a body of gas cannot exist adjacent to a vacuum. Otherwise, our atmosphere would simply expand into the infinite vastness of space immediately. Okay, so I'm not sure how much time I've got left on this thing. I might have to do 2 of these, but, you know, one thing that I talk about a lot is the flight times conundrum, and I hope this air conditioning unit doesn't mess up the sound too much, so I'll cut it off shortly. One proof I like to point to a lot is the flight times conundrum. If a plane traveling from New York to LA is 2,500 miles, has an identical duration to its return flight, then whether y'all know it or not, that actually totally proves that our world is stationary. And I know there's a lot of arguments against this, including the planes traveling at the same direction or speed at the Earth before takeoff, or the atmosphere spinning, 1,000 miles per hour towards the east, just like everything else. I've heard arguments about angular momentum. These people are all missing the point. You got to imagine a westbound flight. Let's say here's your plane. A westbound flight from New York is going to be traveling in opposite directions as the destination. So a westbound flight, once it takes off, it's going to lose its eastbound velocity. We've got jet engines attached. It's not going to continue going east forever. Traveling east with the spin of the Earth forever. It's going to head west. Okay? So with the plane going from New York to LA, traveling in opposite directions as the destination, 2 are going to meet very quickly. It's going to be a short flight. Okay? Now, on the other hand, you've got the plane heading from LA to New York, going east. The world spins east. So when the plane takes off, and we'll just assume that it can somehow keep up with the Earth, which goes 1,000, and the plane only goes 500. But we'll assume that the plane can keep up with the Earth and catch up. Listen, guys, it's impossible for the 2 durations to be identical on a spinning globe. Okay, I'm not just making this up. I've thought this through. People try to make it more complex than it is. It just simply has to do with relative difference in speed. Objects traveling in opposite directions will have a much higher relative speed than objects traveling in the same direction. It doesn't matter how fast they're going or not prior to takeoff or whatever. It just has to do with objects traveling in opposite directions will be coming towards each other, and objects traveling in the same direction will need to race against each other. And the 2 flights would be wildly different in duration. It's not that complex, but people just don't seem to get it for some reason. Or they don't want to get it. They don't want to see the truth of it. Doesn't make any sense, guys. None. No sense. The laws of perspective are easily used to trick people into thinking that we live on a globe, but that's all it is a trick. I really do invite you guys to watch some of my videos. It might be an interesting thing to watch, because I really only started making videos when I started my channel. And I've been, I'm self-taught. I took a couple of not courses, but like video tutorials on different softwares, and so I'm definitely an amateur. And I plan to make lots and lots of more stuff for my fans. People have been bugging me to put, my welcome page thing. So hopefully this has been close to 10 minutes. For all I know, it's been an hour or so. I may do a couple of these if I don't look and seem totally crazy. I don't know how this lighting looks, but at any rate, thank you guys so much for watching. I invite you to check out all of my flat Earth stuff first. It is the most important topic of our time, of probably any time. I believe it is the Great Deception, foretold of for a couple thousand years, if not more. And we really need to be careful not to dismiss this topic off of hand, because it really is indeed the verified truth. I could go on for hours as to how this has been proved, but the dimensional model of our world here. Okay, but that inward force allowing you to walk around on the outside would necessarily need to be equal and opposite to the outward thrust. Okay, so it's going to be the exact same amount of force that's causing you to hang on like this and want to be flung off the thing. Okay, it's got to now hang on, and then let's just go a step further and say there was an equal and opposite force that allowed you to simply walk around on that outside edge of the gravitron with the diameter of radius of 100 miles. That inward force allowing you to walk around on the outside is a stupid thing to think about, agreed. But keep in mind, we are talking about the conventional side. You'll be spinning around the thing at 113,000 miles per hour. You're going to have a tough time hanging on. That's a lot of outward thrust. You'd have to be very strong, and personally, I can pretty much guarantee you it would be impossible to hang on, even with chains holding you on, because of your inertia. But at any rate, if you could somehow expanding infinitely into the infinite vacuum of space, which doesn't exist, by the way. So at any rate, the amount of force needed to keep you stuck to the side of the gravitron traveling 113,040 miles per hour, if that amount of force was applied to the gentleman in the center, only spinning 3 times per minute, balance that out, it's got to negate that, and we'll call that inward thrust gravity. Okay, because that's exactly what gravity is supposed to do. You mix it in with some barometric pressure, which has all sorts of problems, including the barometric pressure or the atmosphere many miles into the air adjacent to the infinite vacuum of space, somehow not